So from the last part, we learned about a typecast will compile or is valid if you do either upward casting to one of the ancestor classes or you do downward casting to one of the descendant classes. Either way, it will be valid. However, now we want to dive even deeper to see what happened at the runtime. Assuming that a typecast actually compile, does it always run okay without running into any exception? Specifically, the exception we want to talk about will be ClassCastException. And the best way to really illustrate this is by using examples. So I got 4 examples to go over with you. I'll go over one by one, but you can refer to the slides. As usual, I will visualize the illustration on the iPad. Okay, I'm going to go over each one of them. 4 examples. Hopefully that'll be enough for you to build understanding and intuition. Let's now start with something simple over here. Let's say we use the student example. Okay, let's say here we got one, and let me now just say compilation. I want to have a very clear separation between compilation, like a compilation time and also runtime. Okay, let's say as far as compilation is concerned, can we talk about line number 1? Line number 1 over here, you can see the right hand side, new resident student over here. Can this dynamic type fulfill the expectation of students? Indeed, it can, right? So this will be okay because non-resident students, which is the dynamic type, fulfills the expectations of Jim's static type, which is students. And the reason is NRS is actually the descendant class of that. NRS is actually the descendant class of students, right? So let me just say this, descendants of. Right, it's really important, okay, for you to see that. All right, let's now go on to line number 2. Will line number 2 compile? Line number 2 actually will also be okay. Okay, let me say first. Okay, but why? For this part over here, are we doing upward casting or downward casting? But how do we judge? The static type for Jim is students over here. That is the static type over here. Let's now annotate it properly. So this will be the static type of Jim. And we are trying to cast that into resident students over here, right? Let me also annotate it. So that one there is resident students over here. So this is the cast type. Cast type. And now are we doing, so going from static type into some cast type, are we doing upward or downward? We are doing downward casting apparently, right? Going from here to here, so that's downward casting. So going from here to here is downward. Okay, so this will be, cast will be okay, so there's a downward casting. Because, oh, sorry, didn't spell it properly. Downward casting. Which will widen the expectation, right? And what about this part over here? You know what? Let me be even more careful over here, right? I think for line number 2, we got different parts over here. So 2.1 is about the cast itself. So 2.1. So this part over here is 2.1. Okay, what about 2.2? So this will be what I call 2.2. 2.2, is that valid or not? Okay, so 2.2 over here, right? So that's a substitution. So the right hand side over here is a static type that results from the typecast, which will be resident students. Can resident students fulfill the expectation of resident students? Indeed, it can, right? So that's why it will compile. Because the right hand side's static type matches the cast type, and which is resident students, which can fulfill the expectations of this resident students. right? Which is RS of the static type of RS, which is students, right? I think it's really important for you to know how to write down the justification. As I said, in the written test or in the exam, you will be expected to actually write such things, such explanation. That's why I'm really trying to show you the standard. Okay, so the right hand side static type matches the cast type, which can fulfill the expectation of the static type of RS. Right, so these are the highlights. Let's look at line number 3 quickly. Can line number 3 compile over here? Line number 3 indeed will compile. It will, because if you look at the static type for the context objects, so that will compile, right? By the way, so far everything compiled. For line number 3, it will compile because the static type of RS, which is resident students over here, resident students, can be expected for the method. Right, you can see set premium rates is indeed declared at the resident student level. Can be expected set premium rates over here. Right, so that's why all the 3 lines will actually compile. So this might be the only example I will try to explain in so many details, but for all the others, you can do similar reasoning. All right. Okay, so everything I have said so far is something you should know, but it's always good to really repeat. Let's now think about what's going to happen at the runtime. Okay, you may have noticed something kind of peculiar already, right? You can see dynamic type for Jim is actually non-resident students, but we are actually casting that into resident students. It's kind of weird, right? But the weird thing is only going to happen at the runtime. As far as the compiler is concerned, they only look at static type. Again, Jim is statically a student. What it is dynamically doesn't really matter. It's not relevant. Because Jim statically is a student, so we will be able to cast that into resident student class statically. That's why we can do that, right? So let's now talk about runtime. Okay, let me now. Okay, apparently I'm running out of space, but I'll put it here. Let's talk about runtime. And runtime wouldn't take so much to write, but I just want to visualize first of all. Okay, if you think about what's happening over here. So let's talk about the objects over here. Let's say Jim. Okay, for Jim, he is pointing to some non-resident students objects. As you can see, dynamic type is non-resident students over here. Non-resident students, and the characteristic feature for non-resident student is the discount rates, not premium rates, right? Discount rates, DR. And then we also got RS over here. When we try to execute this particular part over here, and let's try to recall what's going to happen when we try to do this cast over here, the purple one, right? What's going to happen at the runtime? So what we do is Jim. So now we are going to create an alias, right? We are trying to create an alias over here. That's going to be the cast. And the cast, let me just draw a little bit better. We are trying to create an alias over here pointing to the same objects. We're not creating any new objects, but just an alias. And the alias is basically going to be the resident students. I'll just RS for short, and then Jim. That's the alias, right? Is this alias really, can this alias really be created? Would that really make sense to create such alias? The answer is no, it doesn't make sense, because let's look at that. This is a cast type for RS. This is the dynamic type, NRS. Can NRS objects fulfill the expectation for the cast type, which is resident students? Can it? Apparently it cannot. This can only fulfill the expectation for RS, the cast type, if NRS is actually a descendant class of resident students, but indeed it is not, right? Let me write it down precisely what's going to happen, okay? So the question is, can dynamic type of Jim, which is NRS, right? Dynamically, Jim is pointing to NRS. Fulfill the expectations of the type that we want to cast into, which is resident students, the cast type, which is resident students. And the answer is obviously no. Okay, I'll write down a little bit more in just a moment. So we're talking about dynamic type of Jim, and also the cast type that we are trying to talk about, right? So we are talking about 2. NRS. Can NRS fulfill RS, right? The answer is no. No. Because NRS, this dynamic type over here, is not a descendant of RS. Okay, NRS is not a descendant of RS. Let me recap very quickly, right? When you're trying to do this particular cast, Jim, since now we're talking about runtime, so we can definitely want to involve the dynamic type. Jim dynamically is pointing to NRS. Can NRS be cast into resident students? The answer depends on whether or not NRS can actually fulfill the expectation for resident students. And in this case, because NRS is not a descending class of resident students, so that's why it's not going to fulfill. So that's why there will be some exception to say your cast simply doesn't make sense. Okay, so now over here, so that's why, because of this, there's going to be some class cast exception, so-called. All right, that's a very detailed explanation about this particular example. You can see the code is actually not that complicated, only a few lines, but there's so many things that are actually involved for you to understand. Okay, let me recap very quickly. For this particular example here, number 1, compilation-wise, every line compiles. However, when you try to execute the code, you're going to run into class cast exception, resulted from this class cast expression over here. And it's because the dynamic type for Jim, NRS, cannot fulfill the expectation of the cast type, which is resident students. More precisely, the NRS over here is not a descendant class of the cast type, which is resident students. All right, that's the complete explanation. Let's now move on to the second example. Okay, the second example is going to be explained in the same way. Okay, instead I'm going to leave some part as exercise for you. All right, let me do that. Of course, if you got trouble reproducing the explanation, you can always come back to me. I think that'll be the best way for you to learn without interaction. Okay, so exercise number 1. Okay, let me use a thinner pen. So exercise 1. Explain why line number 1, line number 2, which can be split into 2 parts, right? Which will be this part over here and also this part over here. Okay, line number 2, line number 1, line number 2, and also line number 3 compile. They all compile. You can explain in the similar way as I did over here. Really try to grab a piece of paper and write down the reason. Okay, if you want me to check it for you, feel free to drop by. That's exercise number 1. And exercise number 2, we got to talk about the runtime, right? So let me now write it down. So now for exercise number 2. Exercise number 2. A class cast exception occurs at line number 2. Why? Alright, so you can also follow the very similar reasoning as I said over here, but let me give you a little bit more visual hints over here. So what you're gonna do is you can see that a phone over here statically is declared a smartphone. However, when we want to analyze whether we'll run into class cast exception at the runtime, the static type is not so important, right? So what we want to look into is the dynamic type over here. Dynamic type for a phone is, if you visualize it, it's going to be Galaxy S21 Plus. So this will be the dynamic type for a phone. Let me annotate it quickly. I'm just trying to give you some hints. So this is the dynamic type of a phone. And we are trying to cast that into this iPhone 13 Pro, right? iPhone 13 Pro. So this is the intended cast type. Intended cast type. And this cast will only be valid if the dynamic type of the variable being cast can fulfill the expectation of the cast type. Valid only if the variables, well, in this case, a phone is the variable. The variable's dynamic type, Galaxy S21 Plus, can fulfill the expectations of the cast type. Okay, which is over here, iPhone 13 Pro over here. And more precisely, it can only fulfill if a phone's dynamic type is a descending class of iPhone 13 Pro, for the reason that we explained before, right? If this one cannot fulfill for this, give me one example. What method is actually expected on this, but this one cannot fulfill? Well, take a look at here. That will be hints for you. All right, so that's about the second example, right? Let's now look at the third and fourth one. They're kind of similar, right? Similar. So maybe for I think maybe for this one over here, I'll leave that as a complete exercise for you. I will rely on you to really do it, or you will just simply come to me for help. Let me just do one more together with you, roughly, on a high level. Okay, let's take a look at one more. Let's say over here we got smartphone and my phone, new Samsung, right? Let's now try to analyze the compilation versus runtime right away, right? Let's now take a look. Let's now talk about compilation. Static type. Oh, let me use a lighter green. Static type smartphone over here. Dynamic type that's proposed is Samsung over here. So now should this be valid? Should this be valid? This will be valid if Samsung is. Oh, sorry. This will be valid if Samsung is a descending class of the static type smartphone, because in that case, Samsung can fulfill all the expectation for smartphone. In this case, yes. Okay, that's number one. Right. Of course, you can still apply the similar reasoning for compilation. I'm just trying to go over that quickly verbally because we have covered that already. Right. How about this line over here? Right. So you can see dynamically it's statically it's my phone, it's actually a smartphone. Now we want to talk about compilation. We are trying to cast that into Galaxy S21 Plus. Okay, is that an upward casting or downward casting? Well, we are trying to cast into Galaxy S21 Plus, right? So that means we are doing a downward cast. And notice one thing that's really important. We say that it's a downward cast, not with respect to the dynamic type, but with respect to the static type. It's really important. Downward cast. Because we're going from the smartphone all the way down to here. Okay, let me just draw a little bit better. So we're going all the way down to over here, right? So this is a downward cast. Downward cast. All right, so that's about the compilation. And then, of course, will this be valid? Right? This expression over here is of static type, the cast type, Galaxy S21 Plus. Can this fulfill the expectation of the static type over here? Indeed, because this is a descending class of itself. Right? So compilation-wise, we are okay. What about at the runtime? At the runtime, you have to bring dynamic type into play. Okay? At the runtime. At the runtime, basically, you will just have to see basically about whether or not the dynamic type over here, so this is dynamic type. Dynamic type. Can this dynamic type fulfill the expectation for the cast type that's intended? Okay. At the runtime, let me write it there. Okay. At the runtime, can the dynamic type of my phone over here and we know that it is Samsung. Fulfill the expectations of the cast type. And we'll cast that into Galaxy S21 Plus. Galaxy S21 Plus. Okay, I'm just writing in the shorter form just to save space. Right, we're comparing dynamic type versus the cast type. All right, that's also left as an exercise for you to really complete all the details for the reasoning for compilation versus class cast exception. If you have been following my hints, the answer should be quite obvious to you. So always, when you are given some questions related to typecast, there will be two separate angles you want to analyze the question. One is about whether or not it compiles, which you only have to worry about the static types, and also whether or not you will actually run into any class cast exception, in which case you have to worry about both the dynamic type and also the cast type. And for the fourth example, I'm going to leave it blank, and then I'll leave that to you to really do the exercise yourself. And the standard of reasoning, the standard of writing down the answer will be should be consistent with how I did it with you for the very first example. All right, let me now go back to the slides over here. And so these are all the 4 examples which I just went over with you. So I will encourage you to really go over them one by one, carefully by yourself, right? I believe by watching the video, you already got the intuition, but hopefully you can also watch out for the details by going over, by writing down the answer yourself for the exercises I gave to you, and also go over the slides. All right, let's now go on to the next points.